The wave equation is a partial differential equation, PDE, that describes how the waves propagates through time, or through a medium. So we will have a function, a starting function of a wave. For example, if we take this wave, this, let's say, consider the x-axis, and this is considered, let's say, the function we are trying to predict. So this is going to be our u, which is the function we are predicting. It's a bit big here, just reduce it. And we will have on here is the x, and the function of u will be, let's take it, for example, black, and we will have an initial condition, let's say a function here. And of course, when we have initial condition, it doesn't mean only we have the location of u or with x. So let's consider this as kind of a string. Now this string will have an initial speed. So we will have again another initial condition. Let's say this kind of initial condition, and here again we will have x here and u in here, and we will have the initial condition, but this time with speed. So let's consider it like this. So let's say we have a string that has this specific initial condition, and we have the speed of the string. It goes up here, it goes up and down, means the middle of the string is quite fast and the tips of that string is just not moving. So this one we will call it u, we call it ut or u slash, let's say. So this kind of situation, what we have in here is we have initial condition that we have a thread, and this thread is moving in a specific speed, and we want to predict what is the behavior of this thread. So this will create a wave, and in order to predict what's going to happen, we will apply the wave equation, which have u, which is this function, this value, and this u will change with x according to the second the second derivative of u with x. This is going to be this part, this segment of the wave equation. It will be multiplied by c square, and c square is a constant that the wave speed will be related to it. It will define basically a property kind of value for that string. And why we c square? Because this equation actually came from actually describing the thread of like a piano, not a piano, yeah, a kind of piano, or this instruments like musical instruments. So they used to take this value to be the tension of that string with the mass or the specific the mass of that string. So this is why they put c square. For us, as we're trying to, or we want to solve the wave equation, is just a constant square. If you want to put it as constant, like c only, is also okay, but usually this is how we wrote the wave equation, which is c square. And then it will be equal to the time, well, the second derivative of u with time. And as time progresses, we can, and by solving this equation, we will basically every time step, if we are doing numerical solution, we can actually solve this problem. So the problem we're going to solve is basically this. We will have initial first the wave equation we have to define in our system. And then we have the left part here is going to be the boundary equation. So this part is going to be the boundary equation, which is in this location, which is 0. things will not move, so it will be 0. And in this location, in the other location, which is here, which is by, things also, this is by actually, and here u equals 0, and here also u equals 0. So the thread we have, we are take it this way and pull it, and just try to like pull it and just leave it. It should be going like this. So this is the problem we are trying to solve. So from here and here is going to be fixed. And on the other hand, regarding the initial condition here, this will be the boundary condition. This is our boundary condition, and here is going to be our initial condition. So what is this initial condition? First, we have u xt, the whole u, this function. We are going to have this kind of, let's say, shape described by sine of x. So this is our initial condition regarding position. But position alone is not enough. We need, this is second derivative equation, so it will be also, we need the speed in which this thread is moving. So here the thread will be moving according to this equation, which is ut is going to be also sine. So here is 0 and here is pi, and is going to follow this the same equation. So that means here is going to have a speed, upper speed, and then at the tips is not going to have any speed, and gradually the speed will increase until the middle and then go down again. So what do we expect in such a situation as a physical system? The thing will go up and down. So this is what we are simply going to solve, nothing more, and of course using pens or physics informed neural network. So how just to experience how these things gonna work, or how the wave equation works, let's have this situation. So this is just online. You can see the URL here. This is just online solver for wave equation, and you can define the initial the initial condition. So in here you define the initial condition. You just do like click and basically just kind of draw here. Oh, I made it bad. Okay, here again, sorry, like this, a little bit more smooth will be this way. And here the speed of the wave is going to be the same way. Let's say it will, this will cause us some trouble this way, let's say, as much as possible the same as before. And here is the boundary condition. The boundary condition is going to be at the tip at x equals 0, and at x equals 1 is 0. And then we just start the simulation. As we can see, it goes up and down as we can expect. Of course, you can do other boundary conditions, like we actually have only 2 here for this system. But of course, if we are once you write your own code, you can change anything you want. But let's say in this system, you can see how things are just simulating very quickly. And with that, we hopefully understand the wave equation and what to expect from the wave equation.